All right, this is just a quick video to summarize, highlight, review some of the ideas from the functions module that we've been studying. And what I've got behind me here is a context, a story that we're going to consider, from which all fit in such a way that what you see is how are you to think about these things so you can apply the thinking to any problem situation, any function relationship situation that you might encounter. All right, so here's the story by which we're going to operate for my example. You got $5,000. You bring it to a place to invest it. And you're just going to let that investment sit and grow for a period of time. So I have two quantities I'd like us to think about. A is the amount of money that we have in this account in dollars, and T is the time in years since 2000. Let's say we went back to 2000, have this $5,000, we invest it, and we're going to watch it grow. By the way, this investment, just for the sake of this example, is going to grow at 6% interest per year. So A's amount of money, T's amount of time in years since 2000. The function that would model this situation, trust me on this, is 5,000 times 1.06 to the T power. Okay, so this is a power of T. This is an exponent. So however many years have gone by, we're going to take 1.06, raise it to that number of years, power, and then multiply that result by 5,000, and we'll find out how much money is in our account. So this is a function relationship, and we use this function notation to describe it. And the anatomy of the function notation is this. A is the amount of money, we would say, is a function of. The amount of money is a function of how long the money's been sitting in this account, time in years since 2000. So A is a function of T. A depends on T. And what that leads us to is, in terms of a graph, A is the vertical number line. A is the dependent quantity. A is the output of the function. A would represent the range possibilities, which we'll get to later. T is the horizontal number line. That horizontal number line is the independent quantity. It's the input to the function. It's the domain, and it's the horizontal number line. So that's just how this always works. This is the convention in mathematics. A of T, A vertical, T horizontal. Now, this function, you don't have to know this, but I just want to kind of get at that. If you had a graph of the situation, maybe that's presented to you, the graph of this situation would look like this. And this is indeed a function situation. The definition of function is this. For every input, for every value on that horizontal number line, for every domain value, there can be one and only one, that is, exactly one output. So in our case, for any amount of time that I might want to consider, 3 years, 5 years, 10 years, whatever I would consider, there's going to be one and only one amount of money associated with that time. When that happens, every input has exactly one output corresponding to it. You've got yourself a function relationship, and this definitely is that. And then in terms of tables, we would say time and amount. So you can make this table any way you want, or sometimes we present you those tables just to use them, but we might have something like this. 0, let's say 5, 10, 15. So suppose I just wanted to show you how much money would be in this account every 5 years. So grab a calculator, grab your phone, whatever you like. Just want to show you how this would work. If T is 0, I would take 1.06, raise it to the 0 power. So 1.06, raise it to the 0 power, and then multiply that by 5,000. So punch that in on a machine, on your phone, whatever, and see if you agree that it comes out to be 5,000. It actually does, because 1.06 raised to the power of 0 is 1, and then 1 times 5,000 is 5,000. What does that mean? When time is 0, no time has gone by yet. There's $5,000 in this account. You know why? Because I brought it there. I put the money in the account. Or I went online and deposited it online. So I put 5,000 in the account initially when time is 0. 5 years have gone by. Take 1.06 to the 5th power. 1.06 raised to the power of 5. Multiply that by 5,000. And I get about 6,691 point about 13 cents if I round to the nearest penny. So after 5 years, my account balance would be $6,691, and don't forget the 13 cents. After 10 years, when t is 10, take 1.06, raise it to the 10th power, and multiply by 5,000. 1.06, raise it to the power of 10. Multiply that by 5,000. And I get $8,954.24 if I round to the nearest penny. And finally, if you just wait for 15 years, you're not doing anything else, you're not continuing to deposit, you're just letting that money grow and work for you. If you wait 15 years, 1.06 to the 15th power, and then take that answer times 5,000. You now have almost $12,000, $11,982 and about 79 cents. So what that means is if you deposit $5,000 back in 2000 and just let it sit there for 15 years, that money would grow to almost $12,000 just by sitting there. So we can express the idea in verbal form. I can tell you about the story. We can write it in what we call function notation or a formula. We can make a graph, or a graph will be presented to you at this stage. Or we can make a table, or a table will be presented to you. And all of these things should tie together, and we should be able to tell the story about what all that stuff means. All right, now for this, we're really focusing on your ability to just be comfortable with the language, the symbolism involved with functions. And so here would be a question. A of 10. We say A of 10. What is it and what does it mean? So A of 10. Notice A of t. A of 10. So 10 is the number of years. So when I see A of 10 in this context, I say that's 10 years since 2000. So that's 2010. And A of 10 says how much money, what's the amount of money in this account after 10 years? So after 10 years, the amount of money is $8,954.24. And if we had to, and you will, had to explain what this means, we would say something like, after 10 years since I deposited $5,000 into this account, 10 years later there would be $8,954.24 if I was to withdraw the money at that moment. Now we can see that in the table. 10 years, there's the amount of money. We could have seen it on the graph had we had a very precise graph. On a test you will have a precise graph. But say this represented 10 years. If I went up to the graph and read over, what I would see here is the $8,954.24. So in terms of that point, it's the ordered pair, horizontal 10, vertical 8,954.24. Now, we can also ask questions, sort of the flip-flop of that. Look at number 2. A of t equals 50,000, sorry. What that says is, what is the amount of time? How many years would it take until the amount of money is $50,000? So I would want to be able to say t is something. I have to figure that out. Now I would figure that out by, if I had a table, I could look at the table and look for at what year would I have $50,000. I could look at a graph and say, in what year is the amount 50,000? Let's say 50,000 was right here. I would go, well, that happened after so many years. I would have some resource by which I could figure this out. For our example here today, I'm just going to have you do a little trial and error. Grab your calculator and just play. take 5,000, I'm talking about this now, take 5,000, multiply by 1.06, raised to the power of, how many years do you think it's going to take? Notice it took 15 years to get to almost 12,000. Let's just for fun, let's try 25 years. I don't know if you can see that, bottom of the screen. After 25 years, the amount is about 21,459. I want to feel how long it's going to take to get to 50,000. So I'm going to try again. Take 5,000 times 1.06 raised to the, let's try 35 years. If I go to 35 years, we're now up to 38,000. Not there yet. Let's try one more. Let's try 40 years. Look at that. After 40 years, we're just a hair over 51,000. So maybe just for fun, let's try 39 years. Now we're just, come on, there it is. We're just a touch under 50,000. So it's somewhere between 39 and 40 years. So the amount of time would be, well, let's just go up to the 40 years because that puts us over the 50,000. So here's what I'll say. T is about 40 years. The main thing I want to get at this is not so much, is it 39, is it 40, is it 39 point something? That's not the important thing. What we really want you to get out of this is, do you interpret this properly? A of t equals 50,000 says, determine what year it would be before the amount of money was $50,000. And just from a little trial and error, it's around 40 years. Vertical intercept. Vertical intercept is right there. Horizontally speaking, we're at 0. Vertically speaking, we're at something. Let's find out. That is, when t is 0, the amount of money in the account is something. When t is 0, the amount of money in the account is $5,000. So my vertical intercept is going to be 0, 5,000. And yes, we always do report that intercept as an ordered pair. The horizontal value is 0, the vertical value is 5,000. Write it as an ordered pair. And if you had to explain what this means, what you would say is, when no time has yet passed, that is at the beginning of this event of depositing money, at the beginning I had $5,000 because that's what I deposited into the account. That's what that vertical intercept would mean. By the way, in this case, this graph, because we're starting with some money in the account and it just grows, notice there is no horizontal intercept. A horizontal intercept, let me do it in a different color because in this case there just isn't one, but a horizontal intercept would be like a point here. If the graph ever was to come down and hit here, what we would be saying is the amount of money is 0, and does that happen at any particular time? So if there was a horizontal intercept, what it would mean is, at what time would there be no money in this account? And it just doesn't make sense in this context. Okay, 2 more things. Practical domain, practical range. So the practical domain, we're talking about this horizontal number line. And we want it to be practical, sensible, kind of connects to the story, this context. And this story or context is, I start in 2000 with some money, $5,000. And I'm going to let it grow. For how long? So the practical domain would be this. We're going to start at year 0. So the bracket says I want to include year 0 in my domain. There is a year 0. There is an initial amount of money, an initial deposit. And I'm going to let that money grow. So this is where we get into the kind of, well, what's the right answer? And there isn't really one. How long, how much time do you want to go by for this experiment? Do you want to think about retirement? So when you're 65, how old are you now? Go that many years into the future till you're 65, or do you want to go, like, maybe you're saving money for some future thing? So you have to kind of determine, I'm going to allow my domain to run from 0 to 10 to 15 to 20 to 30 to, or maybe I was going for this $50,000, in which case my domain would have to go to 40 years. You're going to have to look at the situation and kind of gauge what would make sense as an upper value for that domain. I can't really tell you like what's the right answer. It just kind of it depends on the context. I don't go crazy. Don't put like 0 to 10 bazillion. What does that mean in this context? Nothing really. But if it's a context, maybe it's in the problem that says you're saving for retirement. Well, then you could gauge an upper value for the amount of time. Practical range. So range, vertical number line, and this vertical number line starts with that $5,000. So I'm going to say 5,000. And let's again, we don't have a right answer here, but let's again go to my little store here. Let's say my goal was to keep my money in this account till it went to $50,000. So in that case, the range would go to $50,000. So I would want to keep track from 5,000 up to 50,000. That's the practical range. Again, no right answer there exactly. You want to kind of look at the situation and put a practical range that makes sense. Well, I hope all of that helps you keep track of function notation and what it all means. We'll find out when the big test comes.